Okay, so we are continuing with our lesson. Can you see this? So we have actually gone through the entire structure of a C programming. Anyone remembers what is this hash include is for? What is this hash include for? Guys? What is the hash include for? What are we doing? It's the header file which contains, so we are including the standard input output library, and inside this header file it contains certain predefined functions. Like one of the example function is this printf. Let's see, is it large enough? Is this better? So printf, what the function of printf is actually defined in the standard input output header file. So you will actually include more functions and libraries later on, like math header file and things like that. So this is actually required standard if you are using all these functions, printf, scanf, and things like that. And then what is this main? What is this main? What is this main declaration here? Yes? Sorry? Entry point, yes, very good. All C programming structure, you must have the main function. The main function is a compulsory function that you must have. You must have this main, and you must have this open bracket and close bracket, and it must be followed by open curly bracket and close curly bracket. So what it actually means is the main function is defined within these two curly brackets. And inside this main function, you can actually have what we call as statements, right? So the first statement we are looking at is actually printf statement. And every statement must be ended with what? What is the ending point of a statement? Yes, semicolon, very good. You must end with a semicolon to indicate that that is the end of the particular statement. Here we are using the printf. Of course, this printf function is to print out certain output. And how you use this printf? All functions will have these two bracket. See, all these functions will have these two bracket. See this bracket and this bracket. So this printf function is actually defined in this header file, and this printf is actually used to print out strings. String. So how do you define string? You use the double quote. There you have the double quote, right? So anything that you have, you need to have the opening double quote and closing double quote. Anything that you write inside is what we call, it'll identify that as string, and it'll print that out, provided that you have the semicolon here. Is that okay? Then you have this return function, return 0. Now this is a statement whereby at later point of time when you actually learn about functions, currently now you only have one function, main. This is compulsory because you want to define where the entry point is. So the keyword is main. So the main is actually the main function. You must have this structure in a C programming. And whenever later point of time you may have some other functions, and the other functions, whenever you put return, it will return back to the main function. Now in this case, when you put return 0, what it means that it will terminate the program. So that's what it actually means. Is that okay? Any questions so far? So that's where we have actually ended in our last class. So we are going to continue under the printf functions. So before that, we're going to go into the subject matter of variables. Let me just change my pointer. Variables. Up to this point, everyone clear? We just saw the structure of C programming. What are the things that minimum you should have for for you to actually compile. Shall we move on? So now we're going to look at variables. What are these variables? So oftentimes whenever we want to do programming, our data, we will be using words and also numbers. And these data, they have to be stored in the computer memory so that the program can actually access and then change them. So these locations in the computer memory are referred to as variables. So in C programming, you need to actually define the variable. You need to declare the variable first. So there are two things. Whenever you want to define, you need to define the data type and give it a name. So if you want to look at variable, this is an example of how a variable actually is stored. So you have your program, you have your computer memory, right? All computers have memory. And you can actually look at memory like storage boxes. You can imagine like storage boxes. So whenever you want to define a variable, remember the two things. One, you need to define the data type. Is it an integer? Is it a string? And second is, you have to give it a value. So whenever you do that, for example, let's say you assign a variable A. You can give any name. You can give any name. And you can define this as, sorry, what did I say? It's supposed to give a name and data type and also give it a name. Those are two things. So you can give it a name, then you can define the value. 25, integer, it's an integer A. So of course this is a middle or high level language programming, which means it will automatically assign in the memory where to store it. So this is, you don't know, you won't be knowing in which specific storage location it is stored, but it is stored in memory, but the program knows how to access them. So it will assign a memory location for that particular variable and it will store. So next time whenever you want to change, it will access back to this location, it will change. So this variable A is an integer because you can see it is 25. This variable, what do you think? What type? Data type? Character, string. Okay, good. Everyone okay so far? If at all, if anything is not clear, just let me know. That's why each time I have to do this. So now type this code. This one. This entire code you type in your online compiler. So you type first, I give you some time to type. Okay, so if you look at this code here, again you will be able to see the same structure. You have the hash include, standard input output, library function, and then you have the main. Now if you see this integer main, int stands for integer. Main, what it actually means is that the main program actually will return an integer value. Then you see in the bracket, you see void. What does void means? Void means this particular main function is not taking any input arguments. So don't worry, later point of time you'll understand what does it mean by taking an input argument. Whenever you put void, it means this function doesn't need any input value, but it will, when you run the code, the main, it will return an integer value or it will give out integer value. Is that okay? So you can see the same structure, integer main, void, then you have the open curly bracket and also the close curly bracket, and you have the return 0, which means terminate the program. 0 means it runs successfully. So if all runs successfully, you terminate the program. So here, what are the things that we are actually doing? Here we are defining variables. How many variables you can see here? How many variables have you declared? 3, yes. You have integer 1, integer 2, and you have the sum. Yeah, 3. So you need two things. One is you need to define the data type. So int means this is integer. And then the second one is you need to give a variable name. Right? So here there are two types of declaration. You can see this integer 1, integer 2 declaration is you are assigning a value to that variable. But the third one, integer sum, you just define the variable only, but you are not assigned any value yet. So minimum for you to define or declare a variable is that you must have the data type and also the name. So integer 1, you store the value 10. So you are initializing the integer value to store this value 10. And then integer 2, you want to store the value 20. Is everyone okay on this part? So this integer 1 and integer 2, the program will automatically assign the memory's location. But you don't know. And you don't need to know because this is high level language or middle level language programming. But in year 2, when you learn assembly language programming, you need to know the memory address. You have to specify. But here you don't need to do that. You just need to define the type, data type, and also the name. And you can assign the variable value. And the sum you just define. There's no value you assign. So now if you actually try to run this program, let's see. So after you have declared your variables, you can now use your variables in your programming code. So what we do, we come up with a simple formula or equation, which is sum equals to integer 1 plus integer 2. So this is a statement. So sum equals to integer 1 plus integer 2. So you know that integer 1 you have already assigned a value which is 10, and plus is the normal arithmetic operation, and you plus with integer 2 which has the value 20. Now when you have these two values added, where will it store the value? Into the variable integer sum. Now the thing is, when you execute the C programming, it's a sequential, it will execute sequentially each line, right? So let's say if you don't have this printf function, assuming you don't have printf function, it will run. In the sum variable, you will have the answer, but you are unable to see, right? Because the only way that you can actually view is through the terminal, the output terminal, right? Where you saw the hello world, that gives an output terminal. But in order for you to display anything in the output terminal, you need to use one of the functions inside the standard input output operation, which is printf function. So this printf, so we will use this printf function to print out the value of sum. Now, in order for us to do so, we will use what we call as a placeholder. So the placeholder has this kind of format. What is it? This placeholder has this format of ampersand. Sorry, this is percent, not ampersand. So you have to use the percent, and then you have to, wherever you put that, the percentage sign. So for example, you see this printf, what do you want it to display? So here, anything that under the double quote will be printed out. So, so when you type this, quote, this one. Here from this double quote to this double quote, whatever that is inside this double quote will be printed out. But in order for you to display the value of the sum, you need to use a placeholder in the string. So the placeholder, you use the percent. Percent not coming. Percent. So percent will indicate where do you want to display the value. And then you have to use the letter D to define the type of data. So D is actually for integer, decimal value. So this is the placeholder. And after the double quote, you will put a sign of comma, and then you will put what variable that you want it to be displayed at this placeholder, which is sum. Sum is an integer, right? So that's why I use the percent %d. So now if you run this, do you see? It's integer 1 plus integer 2 equals to 30. This 30 is actually the variable sum passed into the string. Is everyone okay? So go back here. Where did we go? So here are the various types of integer data types. So integer data type is used to store the whole number integer values, whole number. So 10, 20, 23, those kind of values is integer without decimal point. There are other data types which can actually store different types of data. So common ones are, you have integer, float, double, and character, char. So integer is one whole number without any decimal point. You have float, then you have double. Both float and also double, it is actually has decimal points. The only difference is the size of data that you can actually store. So you will see that later. But both float and double, you can actually use to store real numbers, which means with decimal points. Char, just like how one of you said, you can actually use to store characters. So char letter means you can actually put one letter, or you can put one whole word also. Is it okay? So integer, float, double, and character. So these are the various data types. So in terms of you can also declare multiple variables in one line. Not necessarily you have to. So hold on. I can't do this multiple. Like here, you see you define the three variables in 3 lines. You can also define it in one single line like this. So just by separating them with comma. So I want you to modify this code, this one, to make it a single line. This one, these 3 lines. Currently you see for every statement you have semicolon, 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 right? Change this one to just define it into one line. So that means you only need to mention the data type once only, that one line. Don't go and put integer x, integer y, integer x like that, no need. Just once, and then you define all the variable names by comma If at all in between you need to assign the value, you assign. So try to do that, try to change now. Okay, so this is the same thing. You can actually define it in one line, single line. Now there are some, now when it comes to the variable declaration, when it comes to naming the variables, naming and other identifiers in C, there are certain rules that you need to follow. You can't use keywords. What are the keywords? These keywords are reserved words in C. For example, you look at this table. These are all reserved words, list of keywords, which means you can't use this name as your variable name. Is that clear? You can't use integer break, for example. You can't define integer break. Break is a special keyword for C, so you can't use it. You can start your variables. Just now you start variable x, y, z, or integer 1, integer 2, sum, right? You can start your variables with alphabets. You can start with numbers, and you can start only with underscore. You can contain alphabets, numbers, and underscore. You start with alphabets or underscore only. So let's say the same variable that you have here. Instead of integer 1, I put one integer. Run. I see you have error. What is the error? So you also must know how to check your error. So whenever you have this error function, it tells you it is actually in the function main. The error is in the function main. It says that, what is the error code? Invalid suffix, integer on integer constant. You see exactly it points. Where is it? This one. And it also gives the line number 13. Line 13. So because of this one error, you'll see multiple errors will actually come out. So the rule is you can only start with alphabets or underscore. If you start with underscore, say integer 1. Oh, sorry. Now why I have error is because I define as underscore integer 1, but then in the sum I'm using an integer which is not defined. So this one also I have to use underscore. Then if you run, no problem. Okay. So you can either start with alphabet or with underscore. Is that clear? This is when it comes to the variable names. Everyone okay? Can we continue? Good. Now, when it comes to naming convention for the variables, a good identifier, the variables also known as identifier naming styles, it will be good if you can have some meaningful word and try to have lowercase alphabets. Use underscore if more than one word. So under these three naming styles, why do we actually want to put meaningful word? For example, just now you want to actually write a code to add two values. Let's say if you put, instead of putting integer 1, integer 2, you actually put chicken and then you put fish. Chicken equals to 10, fish equals to 20. You are giving the variable name, but does it really make sense or not? Why you want to put chicken there and why you want to put fish? When someone else reads your code, they'll be wondering, why did you actually put that? So it's not a very good practice. So that's why they said you try to use some meaningful word that could reflect what you're trying to do. And the second one, why you want to use lowercase alphabets only? That is because these variables, they are case sensitive. The variables, they are case sensitive. So let's say if you accidentally defined it as capital I, integer 1, but then later point of time you use small letter, you'll have error. So ideally, if you want to use lowercase, then it's easier for you to do lowercase. And if you have more than one word, integer A, for example. So you can straight away type as integer A, or you can put integer underscore A equals to so and so value. Okay, so far? So this is I've already explained on the printf function. Printf function has this double quote. Whatever's inside, it prints it. It actually identifies that as a string format. And we have also seen how we can actually also use to print variables. And it also allows for output formatting. So in order for us to print variables, we have seen earlier the placeholders always starts with the %, and also the data type. And you pass the variable that you want to print. So you can see that the %d is a placeholder to print an integer. The variable sum is written after the quotation, separated by comma. So therefore what happens? The placeholder %d automatically will be replaced with the sum value, and that's why you get the output like this. Okay, so far? So these are the various types of placeholders for the common data types. For integer, either you use %d or %i. For float, you use f. For double, also use f. For character, you use c. So you can also print multiple variable values within a single printf statement. So for example, let's say you have this one, value 1, %d, value 2, %f, then x and y. So can you modify your statement now to do that? Which means, go back here. Here, I want you to change it in such a way that you will have the value of integer 1, value of integer 2 being displayed, and also the value of sum. So remember that whenever you have multiple this thing, remember you have to just put a comma here. If you don't put comma also it's okay, but this one, the %d. So all this thing must come inside the double quote, your placeholder. So what do we want to change here? So let's say this one, I'm going to use integer 1. Integer 1 is what type? What's the data type for integer? Guys, what is the data type for the integer 1? In, what is in? It's integer, right? So integer means what is either you use %d or I. So let's use %d. Then I'm going to use comma. Then I'm going to also display integer 2. Integer 2 is also what type? It's also, then I'm going to have sum. Sum is what type? This is also integer, right? So here I can actually put integer, wait, I can't see. Integer 1, comma, not integer. Integer 1, integer 2. Here just put integer 1, integer 2, and sum. So here the format is within the double quote. This is what you want it to display, and you're having the placeholder inside it, right? You can also try with I. Then you have the comma. I'm actually pressed enter so that because otherwise you can't see. I'm going to display integer 1, the first placeholder, integer 2, second placeholder, and sum in the third placeholder. Oh, sorry. Having an error because mine I have to put the underscore. Never mind. Let's make it same. So just integer. There. Everyone managed to get it? So whenever I want to take attendance, what's the last thing modification that we did? That should be there. Everyone okay? Need time to type this? Respond. So far it's not difficult, right? You can follow. Now, earlier we saw that printf you can use to print the variables. That's what we actually use a placeholder. And you can also allow for output formatting. So output formatting is what we'll actually see here. So there are more reading materials that you can actually see. So there are certain format specifier. So like for example, you see in this line 7, you have the %f, pi, no format. So you can see the %f /n means it's a new line. \n means new line. I think it's somewhere in the slide there. This is what we call as the escape sequence in programming. Whenever you see \n, this means the next line will be a new line. If you use \t, you will include the tab. The line will be tab. This is \\. This is to print out the character. So here you can see there are various types of format. So can you try to type this from here to here? So I've included the additional code here. Type here. So here we can see that I'm defining a variable by the name of pi, pi, and it is double. Why it has to be double? Can it be integer? It can't be integer because pi value is 3.14159. It's actually a floating point. So define it as double. Now we are using all these formatting functions. Earlier we have seen how to output the variable, display the variable. Now we are looking at the formatting functions. So there are 5 formatting functions that we're going to see here. So the first one is no format. That means normal. %f. Now we are using the \n so that you'll have new line. Take note that I have actually included \n here, so that each printf function will be new line. So here the first one is maybe can you all watch here first? Look on the screen first, otherwise you tend to miss out. So here %f \n. So this one is no format. No format means it will display this as it is. There's no format, it will follow whatever it is. And you are passing the variable pi, right? So it will display in this %f this value. No format. You're not applying any format. The second one is with precision. So whenever you put the %, then you put .3. .3 means it will take 3 decimal point. Is that okay? 3 decimal point. So you're formatting how you want to display the value. The third one is width. So here you see in front of the F you use 10. 10 means how many characters that it will display, how many digits it will display. So if it's less than 10, this is how many? 1, 2, 3, 4, 5, 6, 7. It is less than 10, right? So it will add padding in front. So you'll see some empty spaces are there. The fourth one, maybe when we actually print out, you'll see the output. The fourth one is the plus symbol. So here you have the percent and you have plus. What does this plus symbol do? Is that it will force the sign to be appeared. So if this value is this is positive or negative value? Positive value, right? So automatically when you display the pi value, if it's positive, it will put positive. If this one is a negative number, it will display the sign negative. So don't think that, oh, because negative number, I'm going to put negative sign. No. Take note that the format here is when you use the plus symbol, it forces to show the sign of the number, whether it's positive or negative. And the last one is combine. So you see you combine, plus sign means you want it to show the number. 10 means total 10 character, 10 digit. 0.4 means 4 decimal points. So when you try to run this, okay, so you see this first one. The first one is no format. It actually will show, by default, no format means it will display 6. 1, 2, 3, 4, 5, 6. So that's why you see we didn't write 0 right earlier. Where is it? There. We didn't write 0. But no format means by default it will display 6 decimal points. So I hope that you are taking notes on all this. By default it will give 6 decimal points. With precision, this is not the precision, we put how many decimal point? 3. So you get 3 decimal point. Then the third one is 10. So do you see that there is a space here? This is 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, sorry, you didn't count that. 10 digits, 2, 4, 6, 8, 9. Sorry, not this one. 7, 8, 9, 10. The digits, not inclusive of the floating point. So this is 10 digit. The plus symbol is a positive, so that's why it automatically appears positive. If it's negative, it will appear negative. So here you combine 4 decimal points, show this one, and also the 10 padding. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 with 10. Anyone have any questions? So how do you want to make sure that you're able to absorb all these things? The only way is by typing code, and later point I'll give you more exercise and things like that. So the more you do, the more you'll be able to absorb. Is that okay? Any questions that you all have? Oh, the explanation is already here. This is I've also explained already. Okay. These are some of the lines. You don't have to type this one. You don't have to type this one. This is actually on the escape sequence functions. Now this one is \n. This is meaning that you'll have a new line. \tab. This is to increase the indentation. Double backslash. Later point of time, we will see how to do comment. Comment is not backslash. It's the forward slash. So please make sure that you know this is backslash. This is backslash. Forward slash is the other way around. So what if you want to actually print out a backslash character? So you use double backslash, it will print out the backslash. So you can see here, the first one, print 5, nothing, this is normal. But because you didn't put any \n, do you see? It actually, the next line, it prints straight away after it. Do you notice that? So the next line automatically comes after the first line. Then the third line, because you have the \n, here you print out line \n7 \n. So which means after you print out the first one, immediately you print out the second one continuously, but then you have the \new line. So which means the next printf will start with the new line, which is here, right there, new line. Then you say new line even inside the string itself. So that means 7 will be new line. Why do you think the line and 7 there is a space here?
Because we didn't put another printf.
No, that's not the reason. Because there is a space here. There is a space here. You see this one, the line, and then the 7. 7 seems to have a gap here. Why are we having a gap? Because after the \n, you put a space. So it actually prints out the space 7. So that's why you have the space 7. Then you see \n new line. So the next line will start with line, but here you use \tab. So this is the standard indentation when you use tab. Then 8, then \n, so which means the next printf will start a new line. You have a line 9, print / character. Do you see this part? Double backslash. Then you have the \n. So here, if you didn't even put \n, it's okay because you don't have any other things to print out, right? But here, when you put double backslash, it will print out the / character. So these are the various, the escape sequence meaning and how you actually print out. So the printf function do not automatically add new line. So we have to specify, the programmer have to specify by putting the .\n. Okay, this one you don't have to type. You're going to type the next one. So this is all explanation that I've mentioned it. So you can actually mix the usage of escape sequence and placeholders, and you can study the example in the following slide. This code you can actually do, but this one you create a new program. You create a new program for this. So just now we had the main function, right? And then we created a new file, but it can only run one in this online compiler. So you need to copy and paste it into the main function. So in this coding, you can actually see there's multiple declaration here. In fact, if you notice that there is also this one shot. Are you able to see? One shot, it actually you assign the integer variable sum, but straight away you equate it with equals to x plus y. So all these declaration are for integer. These are all double. You can also do the area and circumference, everything in this same line itself. So because all are double type. So when you actually print out this one, the first one, number, do you see whenever you use tab? So you can see there is a tab. Calculate, tab again, results, new. So what is this? You are like printing a table. So you are creating the header, which is number, you put \t, tab, calculate, tab, results. Then you have the number 1, you want to display the x and y. So the result, you are using tab, tab, double tab. You are having this double tab. So that's why from X here you have one tab, then you have another tab, double tab. Then you are displaying the %d, which is 30, which is sum. Then you use new line. In between here, you are calculating what is pi. The area of pi is pi squared times r, right? (2 pi r). The formula is 2 pi r is for you to calculate the area. So you've already defined the double here, and then you're printing again. This is number 2, tab. You get tab here. Then you display the area. Then you have double tab. Sorry, you have double tab. So 1 tab, 2 tab, double tab. Then you are using %f. So you're displaying it. That's why automatically you get 6 decimal point. No format. This is without format. Then here \3. So you get back new line 3, and then your tab again. So you get this tab. Then you have circumference, single tab. Then this is %f, %f, which means no format. So here there are 2 placeholder. The first placeholder is you will be displaying the area. The second placeholder you're displaying circumference value, which is you have already given the formula here. So you will take the pi value number and also the r, it will multiply and display. And then the last one, 4th tab, you have volume, double tab, you have double tab, and then you're displaying the value, which is volume. So volume is actually 4/3 times pi r cubic. So you're displaying this value at this placeholder. So in this way you're combining the various variables declaration together with the printf output formatting and also passing the output variables. So this is what you actually get. So I'll stop the recording.